Hi, hello. I'm not sure if the microphone's working or not, so wave if you can hear me.
Seems to be doing something.
Doing something. Can you hear me? Yeah. Okay. So yes, I am Stuart, not Cassidy. Kathryn's over there. You've possibly seen her around. You probably haven't seen her around. So yeah, I received some criticism for this that my titles were too dull and they were always something at DRI. Apparently that's no good. So taking inspiration from the program, I thought I'd go with something else. I was trying to be creative. I think this will carry on, to be honest. That's Harry Clark, by the way, so I'll go back to it later, so it's at least appropriate. I won't bother with the standard DRI blurb. The URL for the repository is there if you want to go and have a look. Just to say we are a consortium of several partners. We started back in 2012. So the good thing about the original title, even if it is a bit dull, is that it does describe what I'm going to be talking about, which is our experience of ingesting objects into the repository. And how we came up with tried to come up with a workflow and a process for doing that. One thing I should clarify is when I'm talking about large, it's our concept of large. I don't think there's a particular number where you go, right, this is small, now all of a sudden it's large. I think it's basically that point where your existing workflows and your systems start to struggle with the volume if it's large. To summarize, size doesn't matter. So okay, first way of ingesting objects, it's pretty much what you'd expect in any web application that creates records or objects. It's a web form. This allows for single objects to be created either through filling out a form, or in our case, XML upload, because we also deal with users who have existing metadata in that format. So this is fine for single objects, even small sets of objects, and objects that only have very small files. But obviously, where you run into problems is when you have complex metadata standards, where you have a very large number of objects to ingest. So repeatedly filling in a form, or even just repeatedly uploading XML gets very tedious very quickly. And the form entry was also complicated for us because we have to support multiple metadata standards. So along with Dublin Core, we also have to support MODS, MARC, EAD. So although Dublin Core maps very easily to a form, you've got easy things like title, description, and so on. When you get into things like MARC, which has numeric codes, that gets very complicated. And then the standards like EAD, which have really complicated hierarchical structures encoded within them, which can't be handled that way. So when you look at forms, like this is a MARC form that was actually made by a colleague here at Trinity for a project he was working on in the repository. It's quite a bit small, but like this form has something like 11 tabs and load of fields. And it's admittedly this was intended for edit rather than ingest, but I wouldn't want to fill out this form once, certainly not several times. So being a developer, when we're asked to do something repeatedly, first thought is to automate it somehow, and that's normally through writing a script, which is just a very short program with a set of instructions on how to complete the task, which can run multiple times. So we did that. So we came up with the command line slide, where you enter the commands in the command prompt. Because we were learning Ruby and starting out with Ruby, we wrote it in Ruby. And the idea was that it just would run locally with the files, the metadata and your content files. There's a bit of a terminology thing here. When we say asset, we're talking about the content, so the image, the PDF, whatever it happens to be. So by arranging those into a defined directory structure, the client can simply just iterate over the directory and ingest each object as it found. So it should be pretty obvious that that's not a particularly great idea. But it kind of stuck around, and problems came when it sort of escaped from the lab, and we thought, we'll just get users to use this and kind of work. So we sort of added some features, added some extra commands, got a bit more complicated, a bit more clever, like restarts and checking status and so on. It ends up looking a bit like this. So lots and lots of commands. And like I say, you know, it did work. But there are lots of problems. First off, people aren't necessarily familiar with command lines, it turns out. Although we use them a lot, most people don't. And we're not talking about non-technical people who these are technical, it's just not something they use. I believe there are people who use something called Windows. Yet to meet one. But that means you're getting into things like multiple platform support, which we really don't want to be doing. It becomes quite difficult to install Ruby. It's not easy to set up, and certainly not easy to set up on Windows. And then clearly the big problem is multiple single ingests directly at the repository. It's a terrible idea. It's slow, it's error prone. It required lots of user support. We had to help people, even the ones that did manage to use it. And basically in the end, we mostly did the ingests ourselves because it was just easier. So just to give an idea of the kind of collections we were looking at and trying to ingest. Although I didn't say numbers are important, there are some numbers. So the first is the Clark stained glass. So this is from Trinity, the digital collections in Trinity. It was in mods. I mean, it's okay for us. It's fairly big. It's about 10,000 objects, split up into 42 sub-collections, and there's just over 20,000 files. It's about 2.8 terabytes in size. So there's two problems there. There's a large number of objects we have to get in, and there's also a reasonably sizable amount of data that we have to try and get there as well. And you sort of think, you know, oh, we've got fast networks. It's no problem, you just upload it, it's fine. Actually, it's generally not. Even moving around any kind of large file becomes a problem. And we have had people just come in with hard disks, because it's actually quicker to just walk in with a hard disk than to try and upload stuff. Then the collection where I was talking about the mark form, was this one. This is another TCD one. This is the National Children's Books collection. So this didn't have a problem with data, great, but it did have over 200,000 objects across 16 sub-collections. So this is this was certainly the largest number of objects we had to cope with. And again, trying to ingest these singly at the repository, well, it just didn't work. It's very slow, lots of errors, lots of timeouts. You couldn't just set it running and go away for several cups of tea because it would break. And essentially trying to do this was a denial of service attack on our own repository. So that was really not good. Another one then is again a different metadata standard. This was the Kilkenny Design Workshop, another really interesting collection, but this was in EAD, so a small amount of data, small amount of objects, but really complicated hierarchy. I'm not going to try and explain EAD because I don't understand it. I don't hate it quite as much as I used to, because ingest for this is actually straightforward. It's a single giant XML file. You throw it at the repository. The repository has to sort it out in the back end, and there's a lot of work that has to go on in the back end to do that. Thankfully, we have someone in Maynooth working on that. Agustina, she's moved to another institution now. But so the good thing was everything happened in the background, magic into the users. They just got this big long structure. There is a problem in that it's basically a one-shot thing. You ingest it, it's created. If you got it wrong, sorry, do it again. edit is also a big problem. So there are things we're still working on. So I'm not for a second suggesting this isn't a problem that people have dealt with. They have these examples out there. One example is Sophia. You can batch create works, terminology change again, but what we would call an object. So you can add multiple files, start the process, and each file creates an individual work. You can associate metadata with, as far as I can see, all of the works, but not individual works. So this is good. This wouldn't necessarily suit our use case because, again, we need to handle multiple standards, we need multiple forms, we need XML. One other that I looked at quite a lot was from Avalon, it's Avalon Media Systems. And they have a batch ingest that is certainly closer to our requirements. It's built around this idea of an ingest package. So you would have your directory of content files, and you also have this manifest file, which is a spreadsheet. And the spreadsheet contains the metadata for each item, and then the path to the content file for that item. If that's good, you can have metadata for individual items, separate content files. And that works by just uploading it to their Dropbox, and then it's processed from there, so it's all done in the background. And that's quite nice. There's other ways that are quite similar. Island Door, for example, I don't use Island Door, but it has also has an ingest that's built around a zip archive where you archive up your content files and metadata and ingest that. And I know from this week, Hydra in a Box are working on a batch ingest that I think also uses a spreadsheet. So there does seem to be some sort of consensus around manifests, online storage, and spreadsheets. So that was kind of the direction the second attempt took. First thing was definitely a web-based UI. Stay away from command line. Being open source, luckily we can borrow from Avalon. So the idea is to upload the metadata XML and the assets or objects, or content files, sorry, into online storage, and then add some kind of manifest spreadsheet that would list the objects you want to create. And then the backend will just take all of that from the storage and run it all as a background task. So for the user, they don't need to see anything other than a status update. So what were some of the things we used? Main thing was Hydra Browse Everything, which is a gem that allows you to browse cloud storage, things like Dropbox and Google Drive. So all the user has to do is put their files in that structure into the online storage, come along in the UI, pick the file you want to ingest to, browse to the storage, get the manifest, and hit go. And then everything is handled on the server side. And then using callbacks, we can just update the status of the UI so they can keep track of how their ingest is running. And they are actually allowed to go away and come back. And they don't have to worry about it. Or they can sit and look at the UI if that's what they want to do. I know in this age we're all supposed to be full stack, and yeah, I can do front end, I can do back end. I can't do front end, so I know that. So I tried it out with some recent Harry Clark sub-collections. They weren't huge, it was about 3,000 objects. Probably about the same amount of data. The files were not huge, but they were reasonably big. So that's the UI. I just threw together so I could keep an eye on things. It gives you the status, which is the most important thing, completed, pending, failed. It still took a very long time, but that's because, I don't know if you can see the timestamps, probably not. I only had a single worker working on these because it was a test. If we scale this out across our workers, it should be a lot quicker. So So the idea is that you'll be able to drill down into your ingests and go to the object level, and then each file. So that's a metadata file and the two assets. So it was about 300 megs. So where are we with that? I mean, I'm not going to say, yeah, it works, I'll just stop it, because clearly there's still a lot of outstanding issues. It is very tempting to tell the user, put it in your Dropbox, use browse everything, which it is, but that's probably not going to work. People aren't really going to want to be doing that. There's lots of size limits on cloud storage. So again, this will probably only be for sort of medium size collections rather than very big. So we'll probably have to provide our own storage that people can use, similar to the way Apple does it. So I've looked at things like Own Cloud for that. Although then I read reviews and I see that Own Cloud is now possibly changing, and we should be using Nextcloud. So I don't know what's going on there. I also thought I'd actually ask a user for a change. And I actually heard spreadsheets being referred to as kind of a lingua franca for the community. So I thought they'd be like, yeah, that's great, we know spreadsheets. Actually, they weren't that. They said, yes, we can do a spreadsheet, it's not a big deal. But actually, we didn't mind creating a directory structure for the command line. That was actually pretty straightforward. Which, to be honest, I was a bit surprised by it, but yeah. So it's possible we might have to do some kind of mixed version where you could either create a manifest or somehow when they upload their files, we'll generate the manifest that we need. So yeah, some kind of hybrid solution is possible. That's yet to be discussed. So I'm not sure if I have much in the way of conclusions. I suppose keep your users in mind when you're creating tools. Probably an important lesson to learn. Make sure you know what their requirements are and their technical, not so much ability, but make something that's familiar to them. Yeah, and if you have something that is clearly wrong and you know is wrong, kill it quick before it becomes entrenched and things start thinking of it as a solution and start trying to use it. Once it gets out there, I think it might get hard to take back. So there we are. That's where we are at the moment.